Welcome to this video lecture on data mining and data preprocessing. I am Smita Suresh Daniel, Assistant Professor from St. Thomas College, Bhilai. This lecture is for MSc Computer Science students of 4th semester. This is paper 3 and unit 2 of data mining and data warehousing. Now, data mining is also known as data discovery and knowledge discovery. It is a process of finding useful information from a data set. Here, data is collected and assembled into a common place, such as data warehouses for analyzing them. They are applied for business decision making and other information requirements that helps in increasing business revenues. Data mining process has the following major steps. First, extract, transform and load data into a data warehouse. Store and manage this data in a multidimensional database and provide data access to business analysts using application software such that they can present analyzed data into easily understandable forms such as graphs and figures so that the company may benefit from the data mining. The first step to data mining is data preprocessing. But what does it mean? Data preprocessing is a data mining technique that involves transforming raw data into an understandable format. Real-world data is often incomplete, inconsistent, or lacking in certain behaviors or trends, and it is likely to contain many errors. Data preprocessing is a proven method for resolving such issues. It prepares raw data for further preprocessing. When we talk about data, we usually think of some large data set with huge number of rows and columns. While this is a likely scenario, it is not always the case. Data could be in so many different forms like structured tables, texts, images, audio files, videos, etc. Machine does not understand free text, image, or video data as it is. They understand in the form of ones and zeros. So it's probably good enough if we put on a slideshow of all images and expect our machine learning model to get trained by that. Therefore, the data has to go through a series of steps during pre-processing. Following are the steps: data cleaning, integration, transformation, reduction, and discretization. Let me show with an example. This is a glimpse of a part of a product review dataset in a raw form. We can see that this has a lot of spelling mistakes. People show lots of emotions on words. They put up reviews in their own ways. So the data is unstructured and this has to be converted into structured format. Data mining techniques helps to make them structured so that it can have useful information that can be extracted from these sentences. For instance, we want to use review dataset for sentiment analysis as the business analysis of a product. There, these sentences have to be converted into a structured format as shown below. It has various columns like positive, very positive, neutral, negative, and very negative. These are the features which has been taken from the above sentences for each of the reviews. Machine learning may not understand text but it can understand the structured format. Hence, the various step of pre-processing has to be applied before converting it into a structured format. The first one is data cleaning, which is a very important procedure because raw data is not at all reliable to be used directly. They have many errors and flaws which have to be corrected first. Thus, in data cleaning, missing values are replaced with some labels. Inconsistent values are corrected. Duplicate values are removed. Noisy data are deleted. Regression functions are used to smoothen data. Clustering is implied to find outliers. Integration is another process to combine together data from different sources into a single place. This is also known as tight coupling. And another approach is known as loose coupling, where many different databases are linked through an interface to obtain the query results. In data transformation process, data is converted from one format to another that is more appropriate for data mining. Some important data transformation strategies are smoothing. It is a process of removing noise from the data. Aggregation is the process where summary or aggregation operations are applied to the data. And generalization is replacing low-level data with the high-level data by using concept hierarchy. Data warehouses or databases may store big data, that is, having data in terabytes of data. So it may take a very long time to perform data analysis and mining on such huge amount of data. So the data warehouses or databases are reduced by using reduction techniques that can be applied to reduce representation of data sets in a much smaller size or volume that contain only important informations. This is known as data reduction in data mining. Data reduction strategies are data cube aggregation, where aggregation operations are applied to the data in the construction of a data cube. A data cube is constructed which has many dimensions for storing different parts of the data. Dimensionality reduction attributes are detected and removed, which reduces the data set size. Data compression is also another method which helps to reduce data set sizes. Numerosity reduction are data are replaced or estimated by alternatives. And discretization is another reduction strategy where raw data values are replaced by some ranges or conceptual levels. Discretization is another technique where we can divide our variables into discrete forms. For example, we can divide a continuous variable weight and store it in the following groups and categories like under 50 kg, between 50 to 70 kg, or over 70 kg. So we have three categories into which we can divide our data and use it for data mining. Concept hierarchy saves the knowledge in hierarchical form, which is then used to generalize mining rules for data mining. Like, for example, in order to search for physics, one has to go through the hierarchy of subject, then science, and then we find the subject physics. There are various methods for concept hierarchy generations like binning, which is a splitting technique which divides a data set into specified number of bins. And another is cluster analysis, where a cluster algorithm partitions a value of a dataset into clusters or groups from a mixture.
Thank you.